In last session, we have discussed about the numerical control as well as direct numerical control machine. In today's session, we will discuss about the computer numerical control machine. So when we talk about the computer numerical control, most of the areas of our manufacturing or the production areas are using CNC machines. CNC is nothing but the computer numerical control machines. So the numerical control is done by using the computers. So control of the machine is done by using numerical way by using the computers. So numerical is nothing but by the programming. So programming is done by the special characters, or it may be the codes, or it may be the alphabets. So by using these different numeric characters, by using these we go for controlling of the machine by using computer, by using the program as well as the softwares. So that is what we are having in the computer numerical control machines. So here, which is dedicated this computer numerical control, which is a numerical control system in which a dedicated computer is built into the control to perform basic and advanced DNC functions, that is the numerical control functions. So to carry out the different areas to perform, we use the numerical control functions here. So CNC controls are also referred to it as a soft wired NC systems, because most of these control functions are implemented by the control by using the softwares here. So software program. So because of that, we call it as a soft wired NC systems. So when we talk about this CNC, which is a computer assisted process to control general purpose machines from instructions generated by a processor and stored in a memory system, which is a specific form of a control system where position is the principal control variable. So all numerical control machines manufactured since from the 17th or of CNC types. So the computer allows for the following storage of additional programs, program editing, running of program from memory, machine and control, diagnostics, special routines, that is in terms of inches or metric, incremental or absolute switchability. So by all these we can control the computer where it is we are having. So CNC machines can be used as standalone units or in a network of machines such as flexible machine centers. So here the CNCs which are of standalone units are in a network, that is nothing but it can be used in a single or it may be used in a network forms to control over the machines. That is what we call it as a flexible manufacturing system. So when the network come into existence, we call this as a flexible manufacturing systems. So the controllers which uses a permanent resident program called an executive program to process the codes into the electrical pulses that control the machines. So these any of these CNC machines, that is execute programs, resides in ROM, and all the NC programs codes are stored in RAM here. So RAM is used for the storing purpose, and ROM, which is a readable memory what we are having. So ROM, which reads the program what we give, and it goes for performing the functions here. So the information in ROM, which is written into the electronic chip, which is written in electronic chips, and cannot be erased, and they become active when the machine is on. So these cannot be erased. So when the machine gets started, automatically the program starts running here. So that is what we are having. So but in when we talk about the that is the numerical control by using tapes or by using the direct numerical control, where the program cannot be stored, it will be erased. when the machines get switch off, automatically the codes will erase. So that was, we are having a problem. So that is been eliminated by using this CNC. So the contents in ROM are almost where the controller is turned off. So some use the special type of the RAMs. So to store this, we use the CMOS memory to store the memory or to store the program, which should not erase. Because of this, we use the CMOS memory, which retains the content even when the power is turned off. So that is what we are having in the computer numerical control. So these are the two machines what we see. These are the computer numerical control machines what we are having here. So when we talk about this history what we are having, so that is from NC machines, that is the numerical control machines, were built in 1940s and 1950 by Professor John T. Parson. So that is a conceived method of using punched cards. That was the what we are having NC machine, that containing the coordinate position data to control the machine tool. So this was the first NC machine what they have come up with in 1940s and 1950 by Professor John T. Parson. So you can see the punched cards which contain commands to control the automated machinery. So you can see the dots. Dots is nothing but the punch here. So on the tape we are going to have a punching. So by using the punched area, punched cards, they were going for running of the machines. So in 1948, Parson demonstrated his concept in US Air Force. This has been done in US Air Force. So next it come into existence of CNC machines, came to existence after the evolution of computer, that is in 1980. Modern CNC machines are improving further as technology is changing with variety of functions according to the application. So you can see the that is a 1959 CNC machine. So Malviki Matic, that is 2, was the first machine with a tool changer. This was the first machine which is a tool changer, where we see the controller. Controller is of a big bulky one what we are having. So to make one CNC machine, this much of the units are needed at that time in 1959. So you can see the different the units what we are having to make one CNC, and which is a huge one. It is a big which consumes more area. That is what we are having. So after this we come into existence of this CNC machines, that is a computer numerical control, that is a outgrowth of the older, that is the removing the NC, which stands to just a numerical control. So right now by using the computer we go for by CNC, where we go for the controlling these programmable automation, numerical control, which is a programmable automation in which process is controlled by numbers, letters and symbols. So the CNC refers to the idea of controlling machine tools programmatically by a computer with the older NC terms. So a computer need not be involved. So this is what we are having, a CNC, so which converts the design produced by the computer aided design software CAD into the numbers. So the numbers can be considered to be the coordinates of the graph, and they control the movement of the cutters. In this way the computer controls the cutting and the shaping of the material. So CNC can control the motion of the workpiece or tool. The input parameters such as feed, depth of cut, speed, and the functions such as turning, spindle off and or turning, everything is controlled by using the computers. So a numerical control system in which the data handling or control sequences and response to input is determined by an onboard computer system at the machine tool. You can see the programming where we can do on the machine itself. We are having a computer where we go for the having a program, that is the program which is fed to the machine directly there. So this is what we are having. So in CNC machines, dedicated computers are used to perform the most of the basic NC machine functions. So the CNC machine, which is a machine, is a NC machine which uses a dedicated computer as the machine control unit. we are having a dedicated computer. So the entire program is entered and stored in computer memory. So this machining cycle for each component is controlled by the program contained in the computer memory. So that the stored part program listing can be used for further production also. So you can see the block diagram of CNC machine. We are having the input device, that is the part programs, which is fed to the machine control unit, where we are having a data processing unit and the control loop unit. For this we are having a display unit. For this we are having we are having a display unit to see all this. So processing of the data as well as the controlling. So processing of the data by motion data, that is given to driving system, that is given to directly to the driving system. So the control loop, that is to the machine, directly the commands which are given to the machine tool, where the process of the functioning or sequence of operation takes place. If it is having any errors or something, it gives the feedback in terms of the that is the position feedback, or it may be the relatively the different type of the functions, water tool exchange or a coolant change, or it may be the exchange of the workpiece. Every signal you will be given to the control loop unit, that is the feedback unit what we are having. By this the whole CNC machine goes on working here. So in an open loop and a closed loop control. So what do you mean by this open loop and closed loop? In an open loop system, there is no feedback given back. That is what we are having. Whereas in closed loop system, we are having a feedback signal. So if we are not having a feedback loop, then if they are having any errors in between the sequence of operation, then the machine goes for shutting off, or the machine stops here. So because of that, or else if we are having any errors in the components, then the errors will not be given. That is what we are having a feedback signal. So you can see the diagram which indicates A, where we are having the pulse train, stepping motor, gear, and the lead screw and work table. So we are not having the feedback here. So if we are not having the feedback, then we are not having any control over the input to the output. We are not having a control over the input to output. So in the same way, when we see the figure B, that is input, comparator, the DAC, that is converter, what we are having, digital to converters, what we are having, DAC, or the servo motor, gear, work table. So when we see the input to the output, the input and output which we are having a control over the output. So inputs are given. In the same way, the output can be controlled by using the feedback signal. That is what we are having the that is what we are having a closed control loops here. So when we talk about the CNC having a feedback signal, that is, it is a closed loop system what we are having, and it works based on the position sensors which are used to correct slide movements and achieve higher accuracy and repeatability. So how exactly the CNC works here? So CNC works based on the programming language which is controlled by G and M codes. So G codes and M codes which are used for the controlling of the machine. These are number, values, and coordinates what we are having. So number, values, that is the values as well as coordinates. So each number or code is assigned to a particular operation here. So that is typed in manual to CAD by machine operators. So G and M codes are automatically generated by the computer software here. So if we are having any design for that one, the design, if we are going to have a design, the same designs for that designs we are going to have a conversion by using the software in terms of G and M codes here. So features of the CNC machinery, where the tool or material moves automatically. Tool can operate in 1 to 5 axis. So when we talk about the 3 axis, we are having the 5 axis also. So 1 to 5 axis, we can have the tool can operate here. So larger machines have a machine control unit which manage operations. Movement is controlled by motors, actuators. Feedback is provided by sensors, that is the transducers. Tool magazines are used to change tools automatically. So tool can be changed automatically by the tool magazines what we are having. So when we talk about the components, what all we are having in the CNC, so the main component of the CNC tools which we want is the input and output console, microprocessor based control unit. So input and output, that is input which is given in terms of the program, and output what we get. In the same way, microprocessor based control unit, whatever the programming we go for having, that has to be run by using these microprocessors, and it has to have a control over the whole machine control unit. So here memory, which is used for the storage, that is whatever the programs we go for, programs we go for using, the programs will be saved in the memory, as well as whatever the feedback signals it gives, it has to store that one. So that is what we are having the memory here. So feedback unit where it gives the signal back, that is a two-way communication we are having. So whatever the feedback it gives to the control unit, which will be given by the feedback unit. And the machine tool, so machine tool is what we are having is the whole unit where we go for the exchange of the tools, exchange of the coolants, or it may be the movement of the workpiece. Everything is done by the machine tools. And interfaces is nothing but interface between the computer to the control unit, or control unit to the machine unit, everything what we are having. So you can see here the block diagram, what it indicates: input and output device, that is input is nothing but the computer what we are having, and the output is nothing but the computer what we get the data signals. So whatever the programs we are having, it will be saved in the microprocessor, and by using the microprocessor it runs here. So memory is the RAM, that is the part program, whatever the program we are having, that programs are saved in the memory. And the ROM where it goes for the control program. So here ROM is a readable, and RAM is the storing data or the storing of the program. So ROM, which reads the program what it is having, and by the microprocessor we go for controlling. So by the microprocessor the machine goes on working, that is a machine tool. And if it is having any feedback signals to be given back, then it is given by the feedback unit to the microprocessor. By this we can have a overall control of the unit, that is input and output is controlled by using the microprocessor. So input, that is what we are having, it is the unit through which a part program is fed to the CNC machine tool system, and required output is taken out. It is basically consists of monitor, right, keyboards as well as computers here. So microprocessor, this controller takes input from input or output device, feedback from the feedback unit, and actuates the drives as well as the tool of the machine tool. So memory, it consists of RAM and ROM. The RAM stores part program, while ROM stores the program for the machine control. Feedback unit, the feedback unit takes input from machine tool and transfers to the control unit for necessary corrections, whatever it is needed. So in the same way we are having the machine tool. Machine tool is operated by the control unit, and interfaces, they are the connection between the different components of the CNC machine tool systems. So these all are the elements what we are having, that is the input device, machine control unit, machine tool, driving system, feedback system, and display unit, whatever I have told. So the same thing what we are having here. So the input devices, it may be the floppy disk, or it may be the connection, serial connection, or it may be the USB, or it may be the computer. Machine control unit, which is the heart of the CNC system. So the subunits, that is the data processing unit as well as the control loop unit. So data processing unit is different, control loop is different. So data processing is the processing of data, that is data which is given, that is program which is inputted to the machine, and the control unit is the feedback what it receives, that is a control unit. So machine tool, this can be any type of this tool or the equipments which are being used. The drive, that is the driver system. The driving system is an important component of CNC machines, as the accuracy and repeatability depends very much on the characteristics and performance of the driving system here. So driving systems, that are nothing but the actuators it may be, or it may be the transducers, or it may be the sensors, or it may be the devices. You can see here the different types of the spindle drives we are having, or it may be the feed, or it may be the speed, everything depends. So driver system plays a very important role when we talk about the precision and accuracy here. So the accuracy as well as the repeatability, that depends upon the driving system here. So this driving system, which is classified as a single spindle drives and feeder drives we are having. So the spindle drives are used to provide angular motion to the workpiece or cutting tool. So you can see the first figure where we are having the spindle workpiece, spindle motor we are having. So the spindle drives are used to provide the angular movement of the workpiece, whereas the feed drives are used to drive the or to slide or movement of the work table here. The movement of the work table, which is done by the feed drives, and the spindle movement or the spindle drive, which is used for the rotation of the workpiece here. The feedback unit, So whatever the feedback it gives, it will be taken by the feedback unit, that is the feedback devices. So display unit is the computer or the display unit for the CNC machines. So the types of CNC machines we are having, so it may be the plasma CNC, or it may be the spring forming, laser cutting machines, flame cutting machines, or it may be the electric discharge machining we are having, water jet machinings we are having, welding by CNC machining, CNC punch presses we are having. So for all, that is when we talk about the manufacturing or the production, we are having this one. When we talk about the quality and control, we are having the computer coordinate measuring machine also we are having. So different types of the CNC machines are this one. So classification of the CNC machine tool systems, according to the feedback system, we are having open loop CNC machines and closed loop CNC machines. When we talk about the according to the type of tool motion control, we are having the finite position control CNC machines as well as continuous path control. So finite position, it is continuous path control machines we are having. According to the program, absolute programming CNC machines we are having, incremental programming CNC machines we are having. According to the type of the controller, so hybrid controllers we are having as well as the straight controllers we are having. According to the axis and type of operation, CNC horizontal we are having, CNC vertical we are having, CNC turning centers we are having, CNC milling centers also we are having. Based on the axis, when we talk about the axis, we are having 2 axis, 3 axis, 5 axis, like this we are having. Based on the axis also we are having. So classification based on the type of feedback system, that is based on the open loop and closed loop system we are having. This is the open loop system CNC machines. So the input program, the microcomputer, CNC controller, drive motor, gearbox and machine tool slide displacement. So here we are going to have open loop. It does not have any feedback mechanism. It also has a also has a motion control, but do not have any provision for feedback, which is needed to be compared with the input to better control and correction of the drive system. So there is no control over the input to the output here. So whatever the errors we are having, these errors cannot be modified, or we cannot change, or we cannot go for the corrections in the open loop systems. So when we talk about the closed loop systems, it is a closed loop system, that is input program, microcomputer, CNC controller, drive motor, gearbox, machine tool, slide displacement, measuring unit. So we are having a closed loop. It is having a feedback mechanism. It has the motion control with the provision of feedback which can be used for accurately controlling the drive system by comparing it with the input information until the required or desired position is achieved. So we are having a control over the output here. Whatever precision, whatever accuracy and whatever we want, we can be achieved by using the control loop type of the CNC machines here. So in the same way, we are having the according to the tool motion, that is finite position control CNC machines we are having. So that is nothing but a finite position is one of the position. So it is nothing but the point to point control here. So from one point to the another point. So you can see here point to point control, that is drilling and boring. So when we talk about the drilling, it starts from one and it ends to the another point here. So from one position to another position. So point to point CNC machines, the movement of the cutting tool from one predefined position to the another predefined position is important, while the path along which this tool moves is irrelevant, commonly used in drilling and punching operations here. So it is a point to point. The tool starts moving from one point to the another point. There is no control over the dimension. So one point to the another point, that is drilling. When we talk about drilling, it starts from one point and it ends at the another point. That is the drilling. Or when we talk about the boring, when it starts from one position and it ends to the another position. That is what we are having, point to point control. So in a straight cut line control mode, which is an extensive version of the point to point method, straight cut is obtained controlling the movement of tool with the controlled feed rate in one of the axis direction at a time, commonly used in face milling, pocket milling and step turning operation. So here we can have a controlling over the movement of the tool with a controlled feed rate. We can have the one of its axis direction at a time here. When we talk about the continuous path control CNC machines, it is continuously with respect to the coordinate system. It starts with respect to one point and it ends to another, and it goes on moving. The tool goes on moving with respect to the coordinate system, Cartesian coordinate system. So the continuous path control system is used for continuous, simultaneously and coordinated motions. That is, if once the tool starts moving, it has to end to the up until all the sequence of operations is over. So it works based on the coordinate system here. But when we talk about the point-to-point control, if one sequence of operation is on, again it comes to the starting point there. But here, when the tool starts moving from one position, it has to end to the another one. So that is, complete sequence of operation is controlled continuously without going to the starting point. So that is what we are having, the continuous. Continuous, it takes the tool goes on moving to complete the sequence of operations here. So the continuous path control system is used for continuous, simultaneous and coordinate motions of a cutting tool and workpiece along the different axes here. So such motion enables machining of different contoured files and curved surfaces. That is, when we talk about the 2-axis, or it may be 3-axis, multi-axis, 5-axis machining, contouring can be done by using the continuous path control system. So when we talk about the programming, absolute programming we are having, that is with respect to the that is the Cartesian coordinate systems, we are having with respect to the geometry system using absolute measurement. Each point is always specified using the same 0 point, or the 0 established for a given coordinate system. So if it goes on moving, that is, you can see here when it starts from P1 to P2, P2 to P3, P4, P5, P6, P7, P8, P9, P10, 11, 12, 13, like this it goes on moving from absolute from P1 to P2, P1 to P3, P1 to P4, like this it goes on moving from point to point. Each point to point is always specified using the 0. So if it goes from P1 to P2, P1 becomes 0. So P1 to P2. So next, if it has to go from P2 to P3, and then P2 will become 0, and it goes from 0 to P3. So like that, each point, starting points, it takes it as a 0 point and it goes on moving in absolute programming CNC machines. When CNC machine, in the same way, absolute we are having coordinate system. In incremental coordinates, that is the CNC machines, the Cartesian coordinate geometry system using incremental measurement. Each point is specified using the path differential from the preceding point position. So in such programming, controller must store and process additional path measurement. So if the tool starts moving from P1 to P2, so it starts from P1 and it goes to P2 and P2 to P3. When it goes from P2 to P3, P2 which becomes the preceding point and it goes to P3. So it will not take it as 0. It goes on moving from one point to another point by using the incremental coordinate Cartesian coordinate system. So it goes on moving from one point to the another point with respect to the incremental varying. So in the same way, in the hybrid control, according to the type of the controllers, we are having the hybrid controller CNC machines. So here the control which is having the both, that is by using the hardwired logic circuits as well as the software computers we are going to have. So the machine control which is done by using the computers, that is the interface as well as feedback. So hybrid, where we are going to have a closed loop system. So controlling is done by using the different logic circuits, that is hardwired as well as interface by the feedback. We are going to have a hybrid controlling. So hardwired logic circuit, it performs those functions for which they are the best suited, such as feed rate, generation and interpolation. So in the same way, we are having the software computer. So the computer performs the remaining control functions plus other duties not normally associated with the conventional hardwired controller. So here hybrid is nothing but it controls over all, that is it acts as a closed loop system. It goes for controlling of the overall machine by using the computer here. So in the same way we are having the stage controller. So that is the computer interface and the feedback. So here we are not having the hardware logic circuits, we are not having the hardware logic circuits or software. So it uses the computers to perform all the functions. The interpolation, feed rate generation and all other functions are performed by the computer with the help of the software here. So the only hardwired elements are those required to interface the computer with machine tool and operators console here. So classification of the numerical control, that is what we are having, that is based on point-to-point control or continuous path, open loop and closed loop. Based on the hydraulic, that is the power drives, that is based on hydraulic, electric and pneumatic, we are going to have a different type of the computer numerical control machines. In the same way we are having position, that is absolute, or we are having or incremental positioning. The hardware and software, hardwired NC, or it may be the software computer numerical control machines we are going to have. So these are the different types of the computer numerical control. So this is what we are having. I already explained this, that is the point-to-point control. With respect to the point-to-point control, we are going to have a movement from one to another point, but the starting point is taken it as 0 and it goes for moving. So to move the machine table or spindle to a specified position, so that machining operations may be performed at that point here. So moving at maximum rate from point to point, accuracy of the destination is important but not the path. So drilling is a good example for the motion control by using point-to-point control. So this is what we are having, that is the path, that is the point is very important, path is not important, tool path is not an important, that is the point 1, 2, 3, the point movement from one point to another point, that is the starting point, it takes as a 0 and it goes on moving here. That is what we are having. So continuous, so to control 2 or more axes simultaneously, we get a desired shape. To control not only the destination but also the path to be controlled through which the tool reaches this destination. So in this process of machining, the tool contacts the workpiece. So it uses linear and circular interpolation methods it uses, and it goes on having the continuous control. This is what we are having, the continuous contouring or the continuous method or the contouring method what we are having. So it starts at the starting point, it goes on moving with respect to the tool path. So according to the Cartesian coordinate system, it goes on moving with respect to the tool path, the tool profile and workpiece. It goes on moving in according to its continuous or contouring positions. So interpolation methods, we are having a linear interpolation, circular interpolation or helical interpolation, parabolic. So when we talk about the linear interpolation, straight line between the point to point or 2 points in a space, we can have a linear interpolation. When we want a circular, so circular arc defined by a starting point, end point or a center or radius and direction by using that. Helical interpolation where circular plus linear motions, parabolic and cubic interpolation, free forms, curves using higher order equation. Based on these methods, the interpolation goes on having. So you can see the inside tolerance or the straight line segment operation, actual curve like this, based on the interpolation by the different linear interpolation or circular interpolation, helical interpolation, parabolic and cubic interpolation. It goes on having the interpolation methods. So control loops, that is the what we are having, open loop and a closed loop. In open loop we are now having no position of the feedback, that is what we are having. In a closed loop we are having a feedback system for the mechanism, that is the closed loop control mechanism. Power drive, that is by electrical motor, hydraulic drive or the pneumatic. The power drives are operated based on electric, that is widely used, which is a small size, easy of control and low cost. Hydraulic drives, that is much larger power as well as size, power to size ratio, that is whenever it is required, that is based on the working or based on the productivity, the drives goes on changing with respect to the machine, that is electric or it may be the hydraulic or it may be the pneumatic. So pneumatic drives, which are rarely used in NC positioning system, can be used to drive the auxiliary devices. So positioning, that is by incremental positioning system as well as absolute positional system. So you can see this example. So when we talk about the absolute versus incremental, the current position of the tool is 20 and 20. So when it moves with respect to x-axis, it is 20, and when it moves with respect to the y-axis, that is which is 50. So 20 plus 30, 20 plus 30, which makes it as 50. But here you can see, so absolute positioning, when we talk about the absolute positioning, that is it moves from x direction, it moves to 40, x direction it moves to 40, and y direction it moves to 50. So that is from one point, from the current tool position, it goes for 40 and it goes for 50. It gives you the absolute. But when you talk about the incremental, it moves, that is it moves from x direction, it moves 20, and y direction it moves 30 mm. So 20 and 30, which gives you the 50 there. So that is what the incremental positioning. So in absolute positioning, each point which it starts, it takes it as 0 and it goes on moving. So that is from one point to the, that is one point to the another point, that is the starting point it takes is that 0 in absolute, whereas in incremental it goes on increment, that is based on increasing or increment with respect to the that is before value or the starting value, which goes on increasing. That is what we are having incremental positioning. So when we talk about the numerical control machines, rating, accuracy, repeatability, spindle and axis, motor or horsepower, or it may be the number of controlled axes, dimension of workspace, features of the machines, and the controller. When we talk about accuracy is more, repeatability is better when we compare with the NC. Spindle and axis motor, spindle, the speed is more, axis, in a different axis we can have a motor rotation, and number of controlled axes we are having, and the dimension of workpiece is bigger. The different size of the workpiece can be handled in the NC machines. So advantages and limitation of CNC machine tools. So before coming to this, we are having the CNC programming basics we are having. So in my next session, I am going to have this CNC programming, basic programming in detail. So right now I will not have this one. Right now I will go for the CNC programming. I will have in the next session. I'll take this one. Right now I will go for the advantage and limitation of CNC machine tools. So when we have advantages, easy of program unit, multiple program storage, we can have online part programming and editing can be done. So easy of program is nothing but we can have a easy of programming for the input programs can be done. Multiple program storages we are having. So multiple program flexibility we are having for the changing of the program with respect to the flexibility. That is, whenever we want to change, we can have a change over the function of the programs. So online part programming and editing. So online part programming, online we can have a part programming and editing. So from the CAD model we can directly convert to the CNC machining, that is in terms of the CNC machining course, directly we can convert from the CAD model, and we can go for the introducing in the CNC machines by using editing. We can go for that one. So use of advanced interpolation methods we are having, automatic tool compensation we are having. The tool compensation is done by using the program languages we are having. Auto generation of part program for existing components we are having. Change in system of units. So the limitation it is having higher cost, the investment, higher maintenance we are having, and require specialized operators. So specialized operators are required for the CNC machine tools. So advantage of this numerical control: short production time, that is time required is less, greater manufacturing flexibility, contour machining, that is 2 to 5 axis machinings can be done. That is what we are having. The disadvantage when is we cannot go by for the using of the, when we talk about the computer numerical control, the disadvantage if is it is having a higher cost as well as the higher maintenance, and which requires a specialized operators. So the main challenges with respect to this is costly setup we are having, that is what the disadvantage. Skilled operators we want, computers, programming knowledge we shouldn't require. And the computer, when we talk about the computer, high-end computers are required for running of the CNC machines. So low-end computers cannot be used for the CNCs. So high-end computers we want with a higher ratio with respect to the storage, memory, or it may be the RAM, or it may be the that is the graphics, everything. It requires the high end of the computers, and it requires the programming knowledge required for that one. So programmer should be there, and he should know the knowledge about the programming. And maintenance is difficult. So maintenance is difficult. That is what we are having. These are the challenges. So the application of the CNC, which includes both for a machine tool as well as a non-machine tool areas. So it will be the lathe, drill press, milling machines, grinding unit, laser, sheet metal pressing working machines, tube bending machines. For all these we are having the CNCs, that is computer numerical control. Welding machines we are having, measuring units, that is the coordinate measuring machine we are having, electronic assembly we are having, tape laying, and filament winding machines for composites. So this technology which is applied to the prostatic and orthotics field as well as. So for all these areas we are going to have a usage of these CNC machines. So when we compare with the NC to CNC and DNC machine, so the NC machine tool, which is the part program which is fed to the machine through the tapes or other such medias. So we should have a tapes in case of NC machines. So right now we are having the CNC machine tool system. The program is fed to the machine through the computer. So the part program is fed to the machine through the main computer. So in order to modify the program, the tapes have to be changed. But here, to modify the program, it is easily modified with the help of the computers. So in order to modify the program, single computer which is used here. So that is what we are having in the DNC. So in NC machine tool system, tape reader is a part of the machine control unit. But here the microprocessor or mini computer forms the machine control unit. So the CNC machine does not need any tape reader here. So large memory of DNC allows to store a large amount of part program. So large amount of part program which is stored by the memory by using the CMOS memory chips. So system has no memory storage, and each time it is to run with using the tapes. So every time the tape has to be wind and rewind takes place here. So winding and rewinding, which is an bulky process as well as which is an time consuming process what it is having. So each time the tape has to be rewind. So that is what we are having. So here in this case it is having that the system has a memory storage ability where the part programs can be stored. So same part program can be run on different machines at the same time. So it cannot import CAD files. So NC machines, where in NC machines we cannot import the CAD files, but here in the CNC machines or DNC system can import the CAD files and convert it to the part program. So the data can be processed using the MIS software so as to effectively carry out the production planning and scheduling. So it can, in NC machines it cannot use feedback system. It cannot, here we are not having any feedback system, but in this we are having the feedback system where the input and output both can be controlled controlled by using the programming language. So we are not having the software driven here. It is a software driven in the CNC and DNC machine. So these are the comparison between the NC machine to the CNC and DNC machine. So this is what we are having today's session with respect to CNC machining. In our next session we will have a detailed study of coordinate measuring machine as well as different types of CNC machines. So it may be the welding or it may be the electric discharge machining. So by using the computer control we are having different types. We will see some of the application with respect to this CNC in our next session. Thank you, students.